for being there with me. I'm glad to have you here. Today, I want us to look at the concept of simple alternating current. And we can say that, yes, a simple alternating current is that current that varies periodically. Or we can say that that current that varies the sinusoidally. And of course, when we say sinusoidally, if we have an equation like this, we'll have a profile where we have current and we have time. Now, current varies periodically. From time to time, this is what you have. And now because of that, because this is not steady, it varies. Keep reversing to and fro. Because of that, we say that this is an alternating current. Now, alternating currents are usually produced by alternating voltages. Because of that, we can now have both alternating current and alternating voltage. They can be represented by the equation that says I is equal to I naught sine omega t for the current, while that of voltage is V equals V naught sine omega t. Now, and of course, this is the angular speed. This angular speed omega can be extended. So by extension, we can now have that I is equal to I naught sine 2 pi ft for the alternating current. While for the alternating voltage, we can have this as V equals V naught sine 2 pi ft. Now let us explain all these parameters one by one. Now we can say that I is the instantaneous current measured in ampere. I naught is the maximum or peak current measured in ampere. Now we can have F as our frequency. F is our frequency measured in hertz. T is a time measured in seconds. Now we can as well have here, this is our omega. This factor here, omega t. Omega t is our phase angle. Is our phase angle, which is as well, it can be written as a theta, because if you remove this, or if you can, this can be represented by theta, giving us that I is equal to I naught sine theta. Okay, so this is our the phase angle. Now we can also have that this alternating current, they can be converted to direct current. How do we convert them to direct current? By using a device. Now for an alternating current has two slip rings. Now if you want to convert it from AC to DC, all you need to do is replace these two slip rings that the AC had, replace it with a single split ring. Now if you replace it with a single split ring, what you now have is a direct current. But you can still, of course, you can move from direct current to AC by this single split ring. It has, you can replace it with a double slip ring. Once you replace it with a double slip ring, you are back to AC circuit. You can as well use a rectifier to do that conversion from AC to direct current. I want us to look at peak and root mean square current. Root mean square current, root mean square current, popularly known as IRMS current. Now this peak is I naught. Now the peak current is nothing but the maximum numerical value of the current, and of course this is the peak. This is the peak. Now while for this, in fact, this is instantaneous current. At any instant on this curve, you can trace. This is I t. You can trace from I, trace it down to t. You can have, let's say here, you can have I1 here. If you trace it down, you can have a T1. If you pick this instant, this point here, you can trace it down to the I axis. Maybe you can have the I2. Then you can trace it down here to have your T2. If you pick this point too, you can still trace it down to have your I3. From here, you can trace it down to have your T3. Now, at any instant, you can get your current. However, you can still get the mean, the average of I1, I2, and the I3. So once you get the average, it gives you this root mean square. Remember, this maximum value here is the I naught. So the I naught, the peak, which is there. Now the difference between the peak and the root mean square, just as we have said earlier, root mean is just the average of the various instantaneous currents. Now we said peak, maximum numerical value, while the root mean square current is just that current that would give you the same energy that will produce or that will dissipate that same current. In fact, it's a direct current, that steady current that will dissipate the same amount of heating effect by any time in a given resistance. So that is the IRMS. In other words, there is a relationship between I naught and IRMS. Now the relationship is that IRMS is equal to I naught all over the square root of 2. And of course, we can extend this by saying I naught times inverse of square root of 2. Now, by that, you can have that is equal to I naught times 1 over inverse of 1.414. 414, and of course 414 is the square root of b. Now if you now take the inverse, you will now have that, or everything is I naught times inverse of this is 0.707. Therefore we can now have that the relationship between IRMS and I naught is IRMS is equal to this over this, or you have IRMS is equal to 0.707 I naught. So either use this or use this. Any of these two equations can go. Now let us take questions to be able to solve that problem. Now we'll take the first one. The first question says the voltage of a domestic supply is represented by the equation. The voltage of a domestic supply is represented by the equation V is equal to 311 sine 314.2 T. So we say that yes, the voltage of the domestic supply is represented by the equation V is equal to 311 sine 314.2 T. Determine the first question. Determine I, the frequency of rotation. 2, the peak value. And then the 3, we have the RMS value of the current. So there are 3 items we have here. So we'll take it one after the other. given this problem we have on the board, the first question says we are looking for the frequency. The second question says the V naught, which is the amplitude voltage, while the third question says V RMS. Okay. Remember, we are given that pi is equal to 3.14. Okay, we now go. Solution. The first thing we do, remember we have the equation given to us as initial. But all we need to do is to compare this equation with the one that says V is equal to 2. V is V naught sine 2 pi f t. Now from here, if we do the comparison, we have that V here is the instantaneous voltage, which is this. V naught, which is the amplitude voltage, is this. So we now have that V naught is 311 volts. Now we are looking for the frequency. Now if you have this, that means we equate these two. We start from here. Equate these two. If we equate these two, we can be able to find our frequency. So which will give us 314.2t is equal to 2 pi f t. Now we are looking for f. F will give us 314.2t all over 2 by t. Remember, t can take care of t. What we now have is a 314.2 all over 2 times, now put the value of pi, which is 3.14. And when we do that, we have 314.2 all over 2 times 3.142 will give us 6.28. Now when you press your calculator, 314.2 divided by 6.28, we will have that the frequency is 50 Hz. Now the second question is the peak voltage. Now from this equation also, this is the first one, the first question. The second question, V naught, and of course from here you can just, because of the comparison, so this is just, this value here is of V naught, therefore we say that V naught is 311 volts. The third question, we are looking for the root mean square voltage. Now the root mean square voltage, remember our equation says that V RMS is that is I naught all over root 2, or you can use the other one. Now if we use this, we can have that V RMS is I naught is 311 all over root 2. So at this point, we can multiply both sides by the value of the denominator. If you multiply it, we now have everything will give us 311 all over root 2 times root 2 all over root 2. And of course, this will give us root 2 times 311 will give us 311 root 2 all over root 2 times root 2 will give us root 4. And of course, root 4 is, it has a value which will give us that our V RMS is equal to 311 root 2 all over. Square root of 4 is 2, which will now give us, and of course, 311 divided by 2 will give us 155.5 or 156. Let's read it. 156 root 2 volts. So this is our answer. Or If the answer is not in standard, it's not on short form, if it's OBJ, please be mindful. If it's OBJ, that means you will still move through. And if we move through, we will now have that 156 root 2 will give us 220.1 volts. So this is our answer. Now let us take the second question. Now the second question says, calculate the peak voltage of a mains supply. Calculate the peak voltage of a mains supply of RMS value 220 volts. Of RMS value, VRMS is 220 volts. And we're looking for the peak. The peak is what we're looking for. Now, this equation can now give us VRMS is equal to V naught all over square root of 2, which will give us, and of course we're looking for we are looking for the V naught, please, not I naught. So we have V naught by cross multiplication. V naught will give us VRMS root 2. V naught will give us VRMS 220 times root 2. And 220 times square root of 2 will give us which is 220 times the square root of 2, and it will give us that V naught is 311.1 volts. So that is our value. Now we'll take the next question. The next question says, the current through a resistor in an AC circuit is given as, the current through a resistor in an AC circuit is given as the current through an AC circuit is given as 2 sine omega t. It's given as 2 sine omega t. Determine the DC equivalent of the current. Determine the DC equivalent of the current. So we now have that I naught is given. From here now, of course, if you compare with the equation, this is I is this. If you compare with our original equation that says I is I naught sine omega t, you now know that yes, from this equation, this value attached here is our I naught. That means I naught is 2 ampere. What we are asked to get is the DC equivalent. Remember the DC equivalent from the IRMS definition. We say that that's direct current that would dissipate the same heating effect per unit time. So that means the DC equivalent is the IRMS. So that is what we're looking for. IRMS is what we're looking for. Now, since we're looking for the IRMS, we now have the IRMS is I naught all over square root of 2. I naught, IRMS will give us I naught already have 2. We have 2 already here. 2 all over square root of 2. What do? Multiply both the numerator and the denominator with the value of the denominator, which will give us 2 over root 2 times root 2 over root 2. And of course, we have 2 times root 2 will give us 2 root 2 all over. Root 2 times root 2 will give us root 4. And we will now have 2 root 2 all over. Square root of 4 will give us 2. 2 into this. Therefore, the answer is equal to root 2 ampere. So this is our answer. Or you can still use the former the other equation that says, so alternatively, we can say that IRMS is 0.707 I naught. So which will give us 0.707 times I naught. The I naught given to us is 2, which will now give us that 0.707 times 2 will give us this. Okay, it will still give us one. It will give us 1.41 ampere. And of course, square root of 2 is still the same thing. Therefore, so we can say either you say it like this or you say 1.41 ampere. Whichever approach you want to take. Remember, in external exams, we don't award marks for taking a very long approach. We award marks for getting the correct answer using a valid means. Okay, now we'll take the next question. This question says, let me clean the board for the next question. Now this question says, if an AC is represented by the equation, I equals I naught sine omega t, calculate the instantaneous value of such a current. If a circuit, if an AC circuit is represented by the equation, calculate the instantaneous value of such a current. If a circuit, it has RMS value of 15 ampere. I RMS value is 15 ampere. If it has yes, RMS value of 15 ampere, when its phase angle omega t, and of course phase angle is 30 degrees. So given that the phase angle is 30 degrees, this is the equation given to us, and we have yes, in an AC circuit we have this, and we are asked to determine the instantaneous value of current. So what do we do? Since we have solution already, we know that this is the equation, and we know that I RMS is I naught all over square root of 2. Now, this is I RMS, and instantaneous current, this is the instantaneous current. And because this is instantaneous current, we do not have from this is what you are asked to get. Here, we have given here to be this. We do not have the amplitude current. So what we will do now is to first get the amplitude current. After getting our amplitude current using this equation, we can now move back, substitute into this in order to get this instantaneous current. So let us go. Now we have IRMS here. If we substitute here, IRMS is 15. 15 is equal to I naught all over square root of 2. Now if you cross multiply, I naught will give us 15 root 2. Assuming we have it like this. Or, and of course, 15 root 2 will give us by our calculator, it will give us 21.21 ampere. So this is our I naught. Now we'll bring it here. If we bring it here, we now have that I naught is I is equal to I naught sine omega t. Remember this omega t is given to be 30 degrees. Here we have our I naught. This I naught, having gotten it to be this, we can say 21.21 sine omega t. Omega t is 30 degrees, which will give us this. So we'll now have that 21.21 times sine 30. And of course, you know that sine 30 is 0.5. Of course, from a special angle, sine 30 is either half or you write 0.5, whichever way. So we can now have times 0.5, which will now give us that I, the instantaneous current, is 10.6 ampere. Okay. Now we'll take the last but not the least question. Of course, after this one, the next one will be for you. Now we'll take this. In an AC circuit, the peak value of the potential difference is 180 volts. The peak value, V dot, the peak value is 180 volts. What is the instantaneous potential difference when it has reached 1/8? When it has reached 1/8 of a cycle. When it has reached 1/8 of a cycle. Now, given that sine 45 is square root of 2 all over 2. So this is what is given to us. All we need to do is to solve through. Given that V naught is that value, and they said, what is instantaneous potential difference? Instantaneous potential difference, V, is what is the instantaneous potential difference when it has reached 1/8 of a cycle, given that sine 45 is that value. So, solution. They have mentioned a cycle. A cycle is just one complete oscillation. Of course, if we have this as a sinusoidal curve, so this is half a cycle, here is a half, this is another half, making it one complete cycle. This is half a cycle, this is another half cycle. So these are two cycles. Now, when I say, recall that one cycle or one oscillation is equal to 360 degrees. Now, since one cycle is 360 degrees, 1/8 of 360, 1/8 of 360 will now give us 1/8 times 360, which will give us 360 over 8. And 360 over 8 by a calculation will give you 45 degrees. Okay, so we now have that the phase angle now, therefore, the phase angle omega t, which is the theta, is equal to 45 degrees. And also we have V naught to be 180 volts. We are looking for V. Remember, our equation says V is V naught sine omega t. See, this is the equation of an alternating voltage. We have this, we have this. All we need to do is to substitute this value. So having gotten this and this, we now say that the instantaneous, please do not confuse instantaneous voltage with the root mean square voltage. So we now have that the instantaneous voltage V, please, is equal to V naught. V naught is 180 times sine omega t. Omega t here is given as 45, sine 45. So which will give us that V is equal to 180 times sine 45, given to us as root 2 over 2. Root 2 all over 2. We now have that V is 100, 180 root 2 all over 2. And of course, 2 can, of course 2 can cancel this to give us that V is 90 root 2 volts. Or you can say that your instantaneous voltage V is equal to 90 times root 2. And of course, from our calculation, we now have that 90 root 2 is equal to 127.3 volts. So this is our instantaneous voltage. Alright, this is what we draw the lesson to an end. Please, thank you for your patience, for being there with me. Please check out in my next video so that we can now continue with other components of the AC circuit. Please, if you have not subscribed to this channel, do me a favor by hitting the subscribe button now. If this lesson was impactful to you, please give it a thumbs up and then check out for the next lesson in few hours. Thank you very much.